Hi everyone. Today's topic is Planck's radiation law in terms of frequency or in terms of wavelength. Here, a black body is considered. It has n number of particles or n number of oscillators termed as simple harmonic oscillators or Planck's oscillators. These particles can vibrate in all possible range of frequencies. Let nu be the frequency. And the frequency emitted by this body is same as that of the vibrating particle or oscillating frequency. Energy is emitted or absorbed in discrete manner, not in a continuous manner, in a discrete manner, discontinuous manner, and the oscillator can absorb energy in multiples of small unit called quanta, and each quantum of radiation is called a photon. Thus, energy is given by nh nu, where n is equal to 0, 1, 2, 3, etc. H is Planck's constant and nu is frequency of radiation. Now, in the derivation part, let the total energy is Et and the average energy is given as E bar, and N be the number of total oscillators with total energy Et. Now, we know that energy is nh nu. When n is equal to 1, E1 is equal to 1 h nu. When n is equal to 2, E2 is equal to 2 h nu. It goes on and on. When n is equal to 0, then E0 or 0E is equal to 0 h nu. So it can be taken as 0. In the diagrammatic representation, energy is taken along the y-axis. Then when n is equal to 0, it is taken as 0 h nu or E0. Then when n is equal to 1, it is 1 h nu. And when n is equal to 2, it is 2 h nu. And then it goes on and on. Now, the average energy of the oscillator. The average energy of the oscillator E bar is equal to total energy divided by n. Let this be equation number 1. The average energy E bar is equal to total energy divided by n. Now, n is equal to the sum of all the individual oscillators or particles present in the black body should be considered. Therefore, n0, n1, n2 and up to nn, because there are n number of particles present. Similarly, total energy is equal to the n0 particle has E0 energy, n1 particle has E1 energy, and n2 particle possesses E2 energy, and the nth particle has En energy. This can also be written as E0 can be written as 0 E and then N0. E1 as 1e n1 and E2 can be written as 2e n2 and En can be written as ne nn. Thus we have total energy and number of total oscillators. According to Maxwell's distribution formula, Maxwell's law or Maxwell's distribution formula, the number of oscillators having energy Ne is given by Nn is equal to N0 e power minus Ne by kBt, where kB is the Boltzmann's constant. Its value is 1.38 into 10 power minus 23. When n is equal to 0, then n0 is equal to, here we are substituting 0, n0 e power minus 0e by kBt. We have 0 in the numerator of exponential power, therefore n0 e power 0, anything power 0 is 1, therefore n0 should be considered as n0 only. When n is equal to 1, then in this equation n1 is equal to n0 e power minus 1e by kBt. Similarly, when n is equal to 2, n2 is equal to n0 e power minus 2e divided by kBt. Now we are going to substitute n0, n1, n2 here from this Maxwell distribution law. So we get n is equal to n0 is written as n0 only from this, and then n1 can be written as n0 e power minus 1e divided by kBt plus n2 n0 e power minus 2e by kBt, and finally nn can be written as n0 e power minus ne divided by kBt. Now here in all these terms n0 is common, so it can be taken out of the bracket. Therefore we have n is equal to n0 out of the bracket 1 plus n0 is taken out, therefore I have e power minus 1e by kBt plus n0 is taken out, so e power minus 2e by kBt, and finally n0 is taken out, so I have e power minus ne by kBt. Let e power minus 1e by kBt is equal to x. So instead of e power minus 1e by kBt, I am going to substitute x in this equation. I get n naught one plus x plus here e power minus 2e by kBt. E power minus 2e by kBt. So here I am going to write that is e power minus x into e power minus x. It is just like a power m into a power n, which is equal to a power m plus n. Similarly, e power minus x into e power minus x is equal to e power minus x plus minus x. So I'll get e power minus 2x. Therefore, since e power minus 1e by kBt is taken as x, similarly one more e power minus 1e by kBt is present here. Therefore, I am writing it as e power minus 1e by kBt into e power minus 1e by kBt is equal to e power m into e power n is e power m plus n minus 2e by kBt. So I'll get this is 1x and this is another x, so I get x square. Therefore, here instead of e power minus 2e by kBt, we will be substituting x square. If it is e power minus 3e by kBt, we will be substituting x cube, and e power minus ne by kBt is x power n. So thus this equation can be replaced with 1 divided by 1 minus x, because 1 plus x square plus x cube plus x power n till x power n, it is considered as series, that is 1 divided by 1 minus x. So the total number of oscillators can be written as n naught divided by 1 minus x, and this can be taken as equation number 2, and previously this is taken as equation number 1. Now the total energy ET is written as E naught N naught, E1 N1 plus E2 N2, or even this expression can also be taken. So we are going to substitute N0, N1, N2 up to Nn using Maxwell's distribution formula. So N has been taken as N is equal to N0 divided by 1 minus x. Similarly, Et is equal to 0e N0 plus 1e N1 2e N2 till n e Nn. Now substituting Maxwell's distribution formula here, we get, since it holds 0e, this term vanishes, we get 1e, n1 is n0 e power minus 1e by kBt. Similarly, 2e n0 e power minus 2e by kBt plus 3e n0 e power minus 3e by kBt plus till ne n0 e power minus ne by kBt. Now we are going to take the first term out of the bracket. Thereby we get e n0 e power minus 1e by kBt. So this becomes 1 plus e n0 e power minus 1e by kBt is taken out of the bracket. So we will be getting minus 1e remaining. From this equation, e power minus 2e is taken as e power minus 1e and into e power minus 1e. In this, e power minus 1e is taken out as a common term. Therefore, the remaining is 2 is here because e n0 e power minus 1e is taken out. So, remaining e power minus 1e is here. So, we get 2 e power minus 1e by kBt plus 3 n0 e and minus 1e is taken out of the bracket. E power minus 2e by kBt will be there. Then plus e n0 e power minus 1e, that is n minus 1. If it is 10, you will get 9 only. Therefore, 10 minus 1 is 9. Similar way, n is here, n minus 1 should be written here. Therefore, n e power minus n minus 1e by kBt. Just I am repeating this. After substituting Maxwell's distribution formula in the total energy of the oscillator, we are taking the first term as a common term. So e n0 e power minus 1e by kBt is taken out. So 1 is taken here and 2, all these are taken out of the bracket. Minus 1e is taken out, so remaining minus 1e is here. So 2 here, inge 1 will be there. Similarly, 3 e power minus 2 will be here. If it is 4, minus 3 will be there. 5 minus 4, in that way it goes on and on. Since it is n, you will get e power minus n minus 1e will be there. That is, whatever number is present here, minus 1 will be in the exponential form. As usual, we are going to consider, let e power minus 1e by kBt is equal to x. Then the above equation can be written as et is equal to e n0 x. This is x. And then 1 plus 2 x plus 3 e power minus 2e by kBt is taken as x square. Similarly, we are going to consider here also the same x square. And then we get n e power minus n minus 1e by kBt is taken as x power n minus 1. That is, if it is 1, we will get x power 0 here. X power 0 is 1 only. Then 2x power 1, 3x square, 4x cube, 5x power 4, and then finally we get n x power n minus 1. One number lesser than in the power. This can be taken as 1 divided by 1 minus x the whole square. Finite geometric series. 1 plus 2x plus 3x square plus 4x cube till n into x power n minus 1. It is taken as 1 divided by 1 minus x the whole square. So we get the total energy. The total energy is equal to E n naught x divided by, instead of this we are going to substitute this, 1 divided by 1 minus x the whole square. Let this be equation number 3. Thus we have the first equation is average energy is equal to total energy divided by total number of oscillators, and then n is derived as n naught divided by 1 minus x, and total energy ET is taken as E n naught x divided by 1 minus x. We need to remember always x is equal to e power minus 1e by kBt. Now substituting equations 2 and 3 in equation 1, we get that is, equation 1 is E average is equal to total energy divided by n. Total energy is E n naught x divided by 1 minus x the whole square. Then n is n naught divided by 1 minus x power 1. For simplification, I am reciprocating these two. Therefore, E bar is equal to E n naught x divided by 1 minus x the whole square into 1 minus x power 1 divided by n naught. Now n naught get cancelled off, and then 1 minus x power 1 and 1 minus x is cancelled off. So the remaining is E x divided by 1 minus x. E x divided by 1 minus x. E bar is equal to, here I am going to substitute x as e power minus 1e by kBt again. We have considered earlier e power minus 1e by kBt as x. Therefore, e power minus 1e by kBt divided by 1 minus e power minus 1e by kBt. For further simplification, dividing the numerator and denominator with e power minus 1e by kBt. That is, divide with e power minus 1e by kBt, and then this is the whole divided by e power minus 1e by kBt. Now, in the numerator, these two get cancelled off. We get e divided by this denominator of the denominator is common to both the values. Therefore, 1 divided by e power minus 1e by kBt minus e power minus 1e by kBt divided by e power minus 1e by kBt. These two get cancelled off, we get 1. Therefore, e divided by 1 divided by e power minus 1e, when it is taken to the above then we get plus, that is 1 divided by e power minus x. When it is taken to the numerator, it becomes e power plus x. Similar way, here also we get e power minus 1e by kbt. When it is taken to the numerator here, in this numerator, we get e power plus 1e by kbt minus 1. Thus, average energy is equal to, now the energy is equal to h nu, we know. Therefore, we are going to substitute average energy is equal to h nu divided by e power, here also we have e, therefore h nu divided by kbt minus 1. This is equation number 4. So this is average energy of the black body. Now, to find the energy density or total energy per unit volume, this is called energy density or total energy per unit volume. The number of oscillators per unit volume with the frequency range of nu and nu plus d nu into the average energy of the oscillator. That is, we know that total energy is equal to average energy divided by total number of oscillators for the whole black body, but here the average energy is common and the number of oscillators n is taken as n of nu d nu, because in the whole black body it is taken as total energy and the average energy and total number of oscillators. The frequency range, it has discrete values. If we are going to consider any two range of frequencies, it may be from nu to nu plus d nu, any frequency range. The number of oscillators in this frequency range is taken as n of nu d nu. So in this way, in a particular volume, per unit volume, the energy density E nu d nu is equal to n of nu d nu into average energy. Instead of ET for the total black body, we are considering within a particular range of frequency. Any range can be considered. That frequency and the difference in frequency is considered. For example, if it is 10 hertz, if it is 12 hertz, then nu is taken as 10 and nu plus d nu is taken as 10 plus 2, that is nu plus d nu. That is what given here as the total energy per unit volume or the energy density within the frequency range of nu and nu plus d nu in a very small volume, in a difference in the frequency range. So how many number of particles are present here? N of nu d nu. For the whole body it is capital N. For a small volume it is n of nu d nu is the number of particles in the frequency range of nu and d nu. But the average energy will be same for the whole black body. So now substituting the average energy formula from equation 4, and n of nu d nu has a value called as 8 pi, it is a number, 8 pi nu square d nu divided by c cube. That is the number of oscillators per unit volume in the frequency range of nu and nu plus d nu is 8 pi nu square d nu by c cube, and the average energy is h nu divided by e power h nu divided by kbt minus 1. Now consolidating, we get 8 pi h nu square here, nu power 1 here. So we get a power m into a power n, we get a power m plus n divided by c cube into 1 divided by e power h nu by kBT minus 1. So this is the energy density or E nu d nu. This equation 5 or expression 5 is called as Planck's radiation law in terms of frequency. Nu is here. If the question is asked for Planck's radiation law in terms of wavelength, then we have C is equal to nu lambda. We have nu is equal to C by lambda. Now, since we have E nu d nu here, 8 pi h nu square into nu, it is nu cube, d nu is here, it is written here, then c cube, this is called Planck's radiation law. Now, in terms of wavelength, if it is asked, C is equal to nu lambda, wavelength is equal to C by nu, and frequency is equal to C by lambda. We have d nu here, therefore, I am rewriting this as nu is equal to C into, this is lambda power 1, so I am taking it to the numerator as lambda power minus 1. Differentiating it, d nu, C is a constant, so C, we have the formula for differentiation as n into x power n minus 1. So we have minus 1 lambda into n minus 1 into d lambda. So we have minus C lambda power minus 2 d lambda, that is minus C by, I am taking this to the denominator, lambda power plus 2 d lambda. So d nu is equal to minus C by lambda square into d lambda. Now substituting d nu as minus C by lambda square d lambda and nu cube as C cube by lambda cube, we get E lambda d lambda is equal to E lambda d lambda is equal to 8 pi nu cube is written as C cube by lambda cube and d nu is written as minus C by lambda square into d lambda, and then the remaining equation is 1 divided by e power h nu is replaced by C by lambda kBT minus 1. Now cancelling the like terms, we have C cube here. So I have 8 pi h nu cube is written as C cube by lambda cube. We have C cube here, and then d nu is replaced with this equation, and then 1 divided by e power h nu by lambda k, h nu by kBT minus 1, that nu is replaced by C by lambda. This is for d nu. Now C cube and C cube get cancelled off, and then 8 pi h lambda power 3 into lambda power 2, we get lambda power 5 and then C d lambda divided by e power hc by lambda kBt minus 1. So negative sign, energy can be written as zero energy or positive energy, but it cannot be expressed with negative energy, so this can be neglected. So this equation 6 is called as Planck's radiation law in terms of wavelength. 8 by hc divided by lambda power 5 d lambda divided by e power hc by lambda kBt minus 1. So consolidating, Planck's radiation law. A black body has n number of oscillators. The total energy is Et, average energy is E bar, and n is equal to individual particles are considered and they are summed up. Substituting Maxwell's distribution formula, we arrived up to n is equal to n naught e power minus Ne by kBt is considered, and we have n is equal to n naught divided by 1 minus x. And then similarly for the total energy, individual particle with their energy is considered, and the same Maxwell distribution formula is substituted for n0, n1, n2 till nn, and then we arrived up to total energy Et is equal to E n0 x divided by 1 minus x square. And then equations 2 and 3 are substituted in equation 1, cancelled the like terms, we arrived up to equation 4, which is the average energy. Now the energy density is taken as average energy into number of oscillators of the given volume, and then for n nu d nu the formula is taken 8 pi nu square d nu by c cube, and average energy value is substituted from equation 4. We get Planck's radiation law in terms of frequency. Now to get Planck's radiation law in terms of wavelength, velocity is equal to the product of frequency into wavelength. From this, the frequency value nu is equal to c by lambda is taken, and nu cube is equal to c cube by lambda cube, that is substituted here. We have d nu, therefore it is differentiated with respect to wavelength. D nu is equal to, since c is constant, it is kept as such, and then lambda is differentiated as on the basis of n into x power n minus 1. Then we have minus c lambda power minus 2 d lambda, or minus c by lambda square d lambda. Then substituting nu cube, nu, d nu values, we arrived up to Planck's law of black body radiation or Planck's radiation law in terms of wavelength.